Let's take a look now at the Arizona monsoon season. The monsoon season is not strictly an Arizona phenomenon. It happens throughout the southwestern United States and the portion of Mexico that's just adjacent to the southwestern United States. So it's actually called the southwestern monsoon, or sometimes referred to as the North American monsoon. But here in Arizona, we call it the Arizona monsoon. It takes place anywhere from July through September on average, and it's called Arizona's fifth season. The official beginning date is now June 15th. The state decided to give it a calendar date beginning a few years back, but traditionally the beginning of the monsoon season was not declared until there were 3 consecutive days with dew point temperature of 55 degrees Fahrenheit or warmer in Phoenix. The average start date of the monsoon season is July 7th, and the average ending is September 13th, with the earliest start on record June 16th, 1925, and the latest start July 25th, 1987. So for the state to set the official calendar date as June 15th kind of jumps the gun a little bit, but the idea there was that they wanted people to be able to prepare, to have time to prepare, to get their roof in order so they don't have leaks, and get their property ready so there's no flash flood damage, or at least minimal. This is an important time of the year for Arizona. It's a dry state. We receive 30+% of our annual precipitation during these few months of the monsoon season. The name monsoon comes from the Asian monsoon season. Monsoon is it's from an Arabic word, mausim, and it references a seasonal shift in wind direction. That's what meteorologically we recognize as a monsoon. In Asia, the monsoon there really produces a lot of rain, up to 400 inches of precipitation. And if you pay attention to the news, the monsoon season is happening now. It's July 2013 as I'm recording, or excuse me, June 2013 as I'm recording this. And there have been a lot of deaths and torrential flooding in parts of India and Asia because of the monsoon. And that's kind of a typical thing to see in the news during the Asian monsoon season. Here's a look at what's happening meteorologically in Asia. This shows the pressure and winds for the winter for January. And if we look over here in India, we see that the winds are blowing from the northeast off of the Tibetan Plateau. So they're blowing off of a landmass. They're going to be very dry, cooler winds. So this is what we see in the winter. And when we look at the same profile for the summer months, this time the average for July, we see now that the intertropical convergence zone, this line here that represents the low pressure band of pressure cells around the equator, has migrated northward because it's now northern hemisphere summer. And with that migration northward, we get this change in wind direction. So now you see the winds are blowing from the south-southwest off of the Indian Ocean onto India. So instead of getting these dry northerly winds, we're now getting these moist southwesterly winds. In Arizona, we have what we call the high desert and the low desert. The high desert is in the northern part of the state, and it's represented by mountains, the pinyon juniper trees, pine trees, and the red rock formations. So the elevations are anywhere from about 4,500 feet on up to the higher points in the state, which can be in excess of 7,000 feet. And then the low desert tend to be in the southern parts of the state, where we see very different vegetation and climate. It's hotter, and this is where we get the saguaro cacti and very different experience in the low desert. So if we look at a map of Arizona to see the topography and the precipitation patterns, you can see here the Colorado Plateau, which is the edge of the Mogollon Rim. So this is a large plateau that extends beyond Arizona of higher elevation, the slick rock, like we know in the Grand Canyon kind of look, and higher elevations. So Arizona has this kind of dividing line between the high and the low desert, where the edge of that Colorado Plateau gives way to lower elevations. And we see it's right along the edge of that plateau where we get the most precipitation throughout the year. These darker areas of purple and blue and green represent higher amounts of precipitation. So they happen along the edge of that plateau, primarily because of forced uplift. Wind flows meet that topography and they're forced to rise up. And if there's any moisture in the air, it will create clouds and potentially rainstorms. Notice also that the precipitation patterns tend down here towards Tucson, which we get a lot of monsoon activity down here in the southeastern portion of the state for meteorological reasons that we'll explore in a moment, and also for topographic reasons. So let's take a look at the typical wind flow before and during monsoon season. So here's our average June airflow up above the surface. So this is higher up in the atmosphere at about 18,000 feet. And we see we have the high pressure cell here that's sitting over northern Mexico. And of course the winds want to blow clockwise around that high. And so our predominant flow here is coming from the west, and some slight winds around the high. Maybe we get a few winds coming up this way. By the time the monsoon season has settled in, this high pressure cell has migrated north. Here it's sitting over the northern part of Texas, and so we still have clockwise flow, and now the flow is bringing with it moisture from the Gulf of Mexico and the Sea of Cortez area, and even from the Pacific Ocean here. So this moist air circulates around the high pressure, and when it's introduced to Arizona and these areas that are experiencing this monsoon season, it's on the western side of this high pressure cell where it can get unstable and turbulent, and that's the recipe for thunderstorms. So you see, this really is a monsoon. We have a shift in wind direction. It's blowing from the west most of the summer before monsoon, and then it starts shifting and blowing up from the south when we get into monsoon season. How do we know monsoon season has arrived? Well, apart from the dew point temperature being 55 degrees or higher for 3 consecutive days, we have something called a surface thermal low. So it's very hot in Arizona in the summer, so that hot air rises up and we get what's called a thermal low. Higher up in the atmosphere, as we just saw, we have high pressure. It's called the Bermuda high, and with it that inflow of moisture. And so there's moist air that is unstable because of the thermal low and the circulation patterns around that Bermuda high. And that's the recipe. That's how we get to monsoon season. It's typically heralded with windstorms in Phoenix that have made the news the last few years, the haboobs, as they're called, these big wind gusts like you see in the picture here that slowly cover the whole city in a complete just chaos. You can't see very far. It's very dangerous driving conditions. Airplanes are forced to land and so on. And it's very windy. So this unstable air is favorable for thunderstorm development, and this series of pictures shows thunderstorm development beginning with cumulus clouds. So when you get a low pressure system like that thermal low, the air is unstable. There's warm air on the closer to the surface and colder air higher up. So anytime you have that kind of configuration, that warm air wants to rise. And if there's any moisture in the air, which we just showed there was, that moisture rises up, condenses into clouds, and we get cumulus clouds, fair weather clouds. If the process continues and these updrafts are strong enough, that cumulus cloud will grow into what's called a cumulus congestus, which can then grow into a cumulonimbus cloud. So cumulus congestus just means that it's topping out, it's going higher up into the atmosphere, it's got some vertical development. And by the time it reaches the cumulonimbus stage, if in fact it does, the cloud has grown as tall as it can get. It's touching the top of the troposphere, and so it tends to spread out into this classic anvil head like you see here. And the warm drafts continue, but now the colder air from higher up in the atmosphere, higher up in the cloud, is forced to sink. And with it comes the precipitation. So we've got this warm air rising up, and then the colder air, these strong downdrafts in some cases, with the rain falling. These downdrafts can be quite intense. They can be the cause of a lot of dust storms, even tornadoes, and a lot of debris flying around in the dusty desert. And then after this process continues for a while, pretty soon the cold air overtakes the warm air, and the cloud is in its dissipating stage. It's no longer growing, it's just releasing what energy it has. Here's a picture of cumulus congestus clouds over the Grand Canyon. Cumulus clouds, before they get to the congestus stage, are just the fair weather, fluffy clouds, but they become congestus if they continue to grow and we start to get some vertical development to them. And then here's a picture of a cumulonimbus cloud over the Sonoran Desert with the saguaro cactus in the foreground, and you can see that classic anvil head on this cumulonimbus cloud. So when you see this, chances are it's going to be raining somewhere. So here's some typical thunderstorm activity. This diagram's a little bit rough, but it conveys the idea. We have low desert and then the Mogollon Rim defining the high desert. And so what happens in the early afternoon, we get thunderstorms over these higher elevation areas. They form from the topography and the wind flow, and they typically develop in the early part of the afternoon. And then the cold air from the dissipating thunderstorm sinks down, right? Cold air sinks, so it sinks down into the valley, and it displaces the warm air, the hot air that's developed in the valley during the day. So all that warm, humid air is forced to rise, and so we end up then with evening thunderstorms typical in Phoenix and the lower desert areas. Typical monsoon behavior occurs in bursts and breaks. A burst is monsoon activity. So we have hot air at the surface, cold air aloft, unstable conditions, and therefore very high likelihood of thunderstorm activity. The breaks are when we have an intensification of the high pressure, which stabilizes the atmosphere, and it temporarily kind of puts a little lid on monsoon activity during the summertime. We have what are called monsoon days. These are days when it's monsoon season and the average dew point temperature is greater than or equal to 55 degrees Fahrenheit. The average number of monsoon days in Phoenix is 56. So that gives you an idea of how many days there's the likelihood to experience monsoon activity in Phoenix. But the range you can see is quite extensive. The smallest number of monsoon days was 27, and the largest 99. So the average tells us a little bit, but when you look at the range, you see it can be really anywhere. The average amount of precipitation from the monsoon season in Phoenix is 2.65 inches. The wettest year was in 1984 when Phoenix received 9.38 inches. The driest was in 1924 when less than half an inch of precipitation was recorded during monsoon season. This map shows the spatial variation in the amount of precipitation that's received during monsoon season. So these ISO lines here represent the percent of annual rainfall during monsoon months. So if we look at Arizona, we see that it's anywhere from 30 up to maybe 60, 65%, or maybe anywhere from 20 to about 55, maybe 60% of the annual precipitation is due to monsoon activity. You can see it's a little bit higher in New Mexico, right? It's not just an Arizona phenomenon, it spreads out throughout the Southwest. And down in Mexico, they have their greatest amount of precipitation happening during this time of the year. One of the hazards of monsoon season are dust storms, very difficult driving conditions, and lightning, major hazard. Arizona is 19th in the nation for lightning fatalities, 30th for lightning injuries. It's the 23rd in the nation for lightning flashes per square mile. And you have to remember that this is all happening within a period of about 3 months during monsoon season. The lightning can be beautiful. You see very dramatic photos, and it's fun to watch if you're at a safe distance, but it can be dangerous. Lightning, of course, can kill. It can strike people, it can strike your home or your automobile, or it can spark forest fires, any number of things. One of the most publicized dangers of the monsoon season are the flash floods. Arizona has a lot of exposed rock with poor drainage in the soil, so those conditions create rapid runoff, and the arroyos, or the ditches really, that drain excess precipitation, become flooded very quickly. And you see situations like you see in this picture where an arroyo spills over onto the road, and it's hard to tell when you're approaching that flood how deep it's going to be. So if you see a sign, the yellow sign, "Do not cross when flooded," you want to pay attention to that. You see amazing sunsets during monsoon season in Arizona. Absolutely beautiful, dramatic skies. And virga is another common sight in Arizona during monsoon season. Virga is precipitation that's falling from the cloud, but it evaporates before it reaches the surface. So you can see it from a distance typically. You can see a cloud that's precipitating. It looks kind of like the one you see here. May not always be at sunrise or sunset, but you see strips of sort of the streaks of cloud and dark streaks below it, showing the rain is falling. And if it's virga, it's not raining on the ground. So you see this fierce rainstorm higher up, but the atmosphere is so dry that that rain just evaporates before it touches the ground. And we get wildflowers. We may not have them during the monsoon season, although I have seen areas where wildflowers just pop up as soon as any rain falls from the sky. But usually it's in the later summer, early fall, after monsoon season. If it's a good monsoon season, there's going to be a beautiful batch of wildflowers that fall. All right, thank you for watching this presentation.